Hey everybody, welcome to week 2 of CS 201 at Oregon State over the summer session. By the way, apologies last week. I ran out of time and I just edited an old video and that's what you had for week 1, but now I'm actually live with you here for week 2. This week, we are actually gonna get into programming, like serious programming. So hopefully everybody got your setup sort of situated the way that you want it. You know, you feel good about it, you feel comfortable writing programs, seeing the output, expressions, operators, variables, and some type conversion stuff. That's what's gonna be sort of on our plates for this week. And really it's just about trying to take mathematical formulas and convert them into statements that you can make in Python that will actually execute the way that you expect them to. Variables are just things that hold on to values because you're going to calculate stuff and need to hold on to a value so that you can use it for a further calculation later on. Or maybe you're just trying to get input from the user, right? So you get input from the user, I need to store that somewhere. Because, if I'm creating like a tip calculator, little app or something that calculates tip, I can't program in the number for the value of the meal. Like that would defeat the purpose of the app, right? Like, I don't know how much your meal cost. I mean, did you get the bottle of wine? I don't know. Like, I need for them to be able to put in a number that could be any number, and then I have to write an expression that can calculate the tip based on that number. Maybe also another factor, like some sliding scale for how well you thought the service was or something. But I need to use those numbers in an expression in order to calculate the tip. And so I have to write my code in such a way that it's set up generically so that I could put in any price, right, and get the correct amount of tip. But that's what all the explorations are going to be about. Taking variables and operators are just like the plus sign. We use a star for multiplication, but you get it. They're basic operators. Now there's more complex operators. We'll get to those later, but right now we're just going to do some math. So but combining variables and operators together to create these expressions, and these expressions can kind of get a little bit bigger, as well as a couple commands. Those commands are going to be really useful. We'll call them function calls later, but those function calls will be really useful for things like getting input from the user, printing stuff to the screen. You've already used that one last week, etc. Probably the more complicated thing this week, if there is a complicated thing, is type conversion, and that's just like, for instance, when you get input from a user, and this is where we'll primarily use it, that input comes in as a string, right? A string is just a series of characters, like English characters. You can't do math on strings, right? So if you're typing in, 98.6, right? That's the temperature you're putting in. That's great, right? But like, I can't do math, even though it's the characters 98.6, I can't do math on that because they're considered characters in the computer language. I need to convert that to something I can do math on, either an integer or a float. The difference between those in computer science, integers do not have anything after the decimal place, which is, you would think that from math, right? And floats do have stuff after the decimal place. Why does that matter? It's because computers actually use integers a lot more than floats. Well, depending. Some supercomputers, because they primarily deal with like scientific stuff, they're actually engineered slightly differently, but let's ignore that. For the most part, on your computer, your memory locations are integers, right? Like, I can't have half of a memory location. The pixels on your screen are integers, right? Everything is either there or not there. So we deal with them in integers, right? It's going to be 48 pixels across. I can't have 48 and a half pixels because there's no such thing as a half pixel. And there's some exceptions to that if you start doing Adobe type stuff there's an exception to anything I say. Point being, your computer treats those entirely differently. In fact, the way that your computer does all of these operations is, and strictly speaking, you don't need to know this because you're not going to have a class after this where you're going to actually have to design crap that does it, right? But like, your processor has different pathways through it to handle different operations. So if I want to add two numbers together, I send them down a particular pathway. I grab the contents of two memory locations and I shove them through a particular pathway, and out will come that addition, right? If I want to do multiplication, I send it down a different pathway. Technically, in the old days, they actually used to just use the addition pathway over and over and over again to handle multiplication. But nowadays, we have a separate pathway. But The pathway to add two integers is entirely different than the pathway to add two floating point numbers. They are treated completely differently by your computer. And so because of that, you need to pay attention to the types, including, well, it could crash your program if you try to like convert something that can't be converted, or even worse than crash is you just get the wrong answer, right? Like that's the worst possible situation where it looks like it's working, but it's not, and it's giving you bad information. The assignment for this week, kind of fun, not terribly hard. I say that's gonna make me sound like a jerk if you're struggling this week. If you're struggling this week, that's normal. You're beginning to learn computer programming, right? That's a standard feeling. Don't feel bad about that at all. Come to my office hours, we'll help you out. But point being, it's gonna be calculating sort of the loss in temperature of a body after death. So you put in a temperature of the body at death, which should be theoretically, and we're gonna use Celsius, 37 degrees. Don't bother with trying to convert Fahrenheit and stuff. We'll just use Celsius for everything. By the way, I also find it funny, 98.6 degrees for the temperature of the human body. Everybody thinks it's like so precise. It's actually not precise. It's actually not even accurate anymore. I saw this Stanford study in Scientific American. Apparently the human body has actually been lowering in temperature over time. So it was like 98.6 around the time of the US Civil War. But right now the actual average temperature for the human body is 97.5. And the whole reason of that point, that wasn't like something specific. It wasn't like, oh, it's so accurate that we have to measure it to the 10th of the decimal place, which people always think. It's just because your body should be around 37 degrees Celsius. And when you convert 37 degrees Celsius into Fahrenheit, you get a decimal place. It should be around 37. If it's 36, 38, you're fine, right? But point being, in that range, it's an average. And it's actually not even an accurate average anymore. So, I'm going off on a tangent. I do this in real life too, by the way. Hopefully I'll edit some of this out. So point being, your program is going to take in a temperature of a body and then tell us the temperatures 1 hour after, 2 hours after, 3 hours after, and 4 hours after. The temperature of each hour is going to be dependent on the temperature the hour before. So for instance, to calculate the temperature after 3 hours, you're going to need to know what the temperature was after 2 hours. So those are going to be variables you need to save in order to keep using them over time. But other than that, the formulas are kind of already in the assignment for you. It's really just going to be about getting input from the user, doing some calculations, providing some output. And I'm pretty sure everybody will do just fine. If not, again, reach out for help. That's what we're here for. You also have this week an optional team challenge activity. These team challenge activities are extra credit. It's just 10 points of extra credit, which, I mean, given that your assignments are 70, you might think it's not worth it. You never know, right? Like it can help offset something towards the end, your final exam or something. But point being, those points are available. You can be teams of up to 4 people. So you're spreading the work out. They are a bit more complicated. So instead of sort of that simple formula for calculating the temperature of a body going down, you're actually going to be using these fancier formulas to calculate an approximate sine, cosine, and tangent for any angle that's been given to you. Do not use the built-in features to actually calculate it exactly. We don't want the exact ones. We want an approximate version using those formulas that are in the Team Challenge activity page. They will not be accurate. And by the way, those formulas say ... You can't do the ... because you haven't learned loops yet. Eventually you could maybe do the ... at least for a while and get a more accurate picture. But for right now, you can't. And so you're just going to be using like the first 4 factors that are just listed there to calculate an approximate tangent, an approximate sine, and an approximate cosine. All right. So that's the team challenge activity. Like I said, up to 4 people. You misstate how you contributed. So make sure that everybody contributes. Everybody knows how the code works, and that you put your name in to say what you actually did. But you can definitely split the work across the 4 people. That's it. That's it for the week. All you got to do is really the one assignment. That's the only thing you have this week. Obviously, you're going to have to go through all of the explorations to figure out how to do that assignment, but the assignment is the only real mandatory thing to do. And then there's that extra credit team challenge activity if you want to do it. If you have any questions, send me a message through Canvas. I'm here for you. I will see you online.